Chapter 9 Practice Test. In problem number 1, they're asking you to convert each of these percents to a decimal. How are we going to do this? Well, recall that to convert percent to a decimal, you're pretty much dropping those percent sign into a decimal. You're converting them into a decimal. You're dropping the percent. So whenever they ask you just to get rid of this percent sign, will mean to drop the percent sign. Alright? If, as we covered earlier, to drop the percent sign means to divide by 100. So this 45 pretty much is going to be 45 divided by 100. So we're going to have 45 divided by 100. Since they want you to convert this to a decimal, we have to use our long division. So you can opt to do this. The first always goes inside 45 divided by 100, and then you proceed to do your long division. However, we can also use the shortcut that says if we're dividing any number by a multiple of 10, in this case by 100, what we need to do is, well, locate the decimal point of 45, which is here, and we're going to have to move it 2 spaces to the left. So one space here and another space here. Therefore, our final answer should be 0.45. So that should be the answer for number 1. Now number 2, they're asking you to drop the percent once again. So I will put here number 2. Number 2 is 0.4%. So they want you to do this into a decimal. Well, let's get rid of this percent sign. We have to drop the percent sign, so we have to divide 0.4 divided by 100. And as I say, you can use your long division here if you wish to do that. Now in this case, I'm not going to do that. I'm just going to apply the shortcut because it's much faster. So move 2 spaces, 1, 2, and your decimal point should be there. But what am I going to do with this space that I'm left? Well, you fill them with zeros. Therefore, your answer should be 0.004. In the next following part, we're having number 3. They say 4 2/5%. So I have to divide I have to do 4 2/5 into a percent first. Before I do anything else, I first need to convert this part here into a percent. So how are we going to do that? Well, we know we're going to have a 4 point something. And what is 2/5 as a decimal? So well, let's convert that 2/5 into a decimal. So 2/5 converted into a decimal, we have to use our long division. So it's going to be 5 here and 2 here. So you're going to put point here, and you're going to be 0. 0 times 5 is 0. Subtract, that's 2. Bring as many zeros as you want there. 1 0, in this case 5 goes into 24 times. So 4 times 5 is 20. It went evenly. Therefore, it means that we're going to have 4.4%. We're going to have 4.4%. Now let's drop this percent sign. How are we going to drop the percent sign? By divided by 100. And once again, recall that you can do your long division. You can opt to do that. However, we're going to move these spaces 2 spaces to the left and fill the rest with zeros. So our answer should be 0.044. So any single time that you have to drop the percent sign, you must convert this. You must divide by 100. Let's do problem number 4. So problem number 4 says 20 2/3%. How are we going to do this 20 2/3%? Well, let's say that first this needs to be a decimal because the question is the instruction saying convert each of these percents into a decimal. So first let's make sure this 26 3/4 is a percent. It's a decimal, so 26 will be 26 whole point. But what is this 3/4 as a decimal? Let's divide. Or recall the 3/4 is like 3/4, so that would be 75 cents. But let's do this division. So 4 goes into 3 0 times. 0 times 4 is 0. Subtract that. 3 minus 0 is 3. We have as many zeros here as we're going to need. And 4 goes into 30. How many times? That should go 7 times. 7 times 4 is 28. We subtract that. That's going to be, we gotta borrow here. 10 minus 8 is 2. 2 minus 2 is 0. Now here another 0 here. Let's bring it down. 4 goes into 20. How many times? 5 times. As we expected, that had to be 75 cents. So this will be 26.75%. But we need to drop that percent, and we need to get rid of this percent symbol here. We must change that into a divided by 100, because if you want to drop the percent, recall that if you want to drop the percent sign, you gotta divide by 100. So that's going to be, well, you can do long division, or you can just move these 2 spaces over, and that should be 0.2675. So let's just recall, any single time that you want to drop the percent sign, you have to divide by 100. In problem number 5 through 8, they're asking you to convert each of these percents into a fraction. So now they don't want you to convert these to decimals. They want you to convert these into a fraction. So let's put here into a fraction. So we're gonna do problem number 5. In problem number 5, you have 6%. Same idea. They want you to get rid of the percent sign. Therefore, you must divide, because get rid of it, or pretty much drop the percent sign, means that you have to divide by 100. So in number 5, we have 6%, which this 6%, I have to get rid of it, so I gotta put divided by 100. But now they're asking you, they want you to have a fraction. So any operation that we're going to do has to be a fraction. So 6 divided by 100 should be 6 over 100. Recall that this symbol here also means divided by. That's what I can just put that into a fraction. So, but is this my final answer? Recall that any single answer that you're given must be reduced to its lowest terms. In the case of fraction, any fraction that you give should be reduced to its lowest terms. So 6 divided by 100, well, we have to use some reduction here. So 6 is 2 times 3, and 100 is 2 times 50. Now I can cancel these numbers here, and I'm left with 1 times 3, which is 3, and 1 times 50. Why didn't I keep reducing? Recall that 3 is a prime number, and 50 does not have any factor of 3. Therefore, your final answer should be 3 over 50. Now, problem number 6. They also want you to convert this into a fraction. But wait a minute. 16.5 is not a fraction. So you first need to convert the decimal into a fraction. So 16.5 should be 16 whole and 5 tenths. So we have the percent so far, but 5 tenths should be reduced into 1/2, right? Do we agree that 5 tenths is pretty much 5 times 1, and this is 5 times 2, which this 5 goes away, and you're left with 1/2. So I'm gonna just rewrite 16 and 1/2%. Now I must drop this percent sign that is here. I want to get rid of that, so I must divide by 100. Drop the percent, divide by 100. So 16 and 1/2 divided by 100. But in our step of dividing fractions, this 2 has to be a fraction, so I have to do 2 times 16 should be 32, plus 1 is 33, and keep the same denominator, 33 over 2, divided by 100 over 1. Now let's do this long division here on the side. So to divide that, I have to change the division into a multiplication statement. So times 1 over 100. Now let's recall that 33 is 3 times 11, and this 100 could be 10 times 10, and each 10 is 2 times 5, but see that they don't have any factor of 3 or 11 in common, so we should just straight multiply that. 33 times 1, which was 33, over 2 times 100 is 200, so your final answer should be 33 over 200. So if they're asking you to make everything into a fraction, convert all of this into a fraction, first of all, that decimal here that was given should have been a fraction. So we convert that into a fraction with the percent sign that we have here, but now we have to drop the percent sign, so it means that we had to divide it by 100. And after that, you follow all your procedure, try to reduce if possible, and we couldn't reduce that, therefore we multiply across. So my final answer should be 33 over 200. So in problem number 7, they're asking you for the same thing. Convert each of these percents to a fraction. So problem number 7, we're going to have 8 1/3%. Hopefully this is already well, it's a mixed number. Let's convert that into a proper fraction. 3 times 8 is 24, plus 1 should be 25 over 3%. But now that percentage here that we have, that percent symbol, should be changed into a divided by 100, because to drop the percent side we must divide it by 100. Well, that 100 is 100 over 1, therefore should have 25 over 3 times 1 over 100. So we have to factor each of them, right? But wait a minute, I think that the 100 could be written as 200 times 4, because that's like 4 quarters, right? And here you can factor as any way that you want here. You could, some students just do, oh, 25 goes into here 1 time, and 25 goes into 100 4 times. You could opt to do that. If you're so used to do that, once again, just keep doing that method. But in this case, I'm just gonna cover what most of you do as well. If that's 25 and this is 3, that 100 is 25 times 4. Now I can cancel those. 25 goes into here once, 25 goes into here once, and now I don't have any common factor, so 1 times 1 should be 1 over 3 times 4 should be 12. So that is the answer for this particular problem. So this was a mixed numeral. That mixed numeral was changed into an improper fraction. You had the percent sign and you had to divide by 100 because you had to drop the percent sign. Drop the D stands for divide, so reduce if possible. In this case was able to reduce, so 1 times 1 is 1 and 3 times 4 is 12. Now let's do problem number 8. In problem number 8, they're telling you to have 0.32% convert this into a fraction. So since this is a decimal, I want to change that into a fraction. So that will be 32 over 100, because that's 3200, so you can do that percent. But wait a minute, this 32 over 100, I have to convert this into a percent sign. So I mean, this 32 over 100, I have to simplify, reduce to its lowest term. But let's recall that 32 could be what? Let's do that on the side. 32 over 100, that's pretty much 4 times 8, and this is 4 times 25. 4 and 4 goes away, so I'm left with 8 over 25%. Now let's get rid of this percent. So to drop the percent means I have to divide by 100. Correct. If I'm gonna have to divide that by 100, I gotta make sure that this is one fraction. So now we have to change that into a multiplication statement. So I will do that here. So we have 8 over 25 times 1 over 100. This 8 is actually 4 times 2 once again, and you have 25, which could be 5 times 5. Let's just write 5 times 5. Maybe there is something in common there, but you can clearly see that there is no 5 on top. So, but this 4 could be a 4 times 20. This 100 could be 4 times 25, and you can clearly see now that this 1 and 1 goes away, and there's nothing else to cancel out because there's a 25. It's not even, so there's not a factor of 2 there, and you have a bunch of 5 here. So pretty much you have 2 times 1, which is 2, over 5 times 5, which was 25, times another 25. After you've done all your calculations for that, 25 times 25 should be 625. So just a quick review. Any single time that they ask you to drop the percent, to get rid of this percent, you have to divide by 100. So if they're asking you to say convert to a fraction, make sure everything that you are involved in is a fraction. If, like in the previous problems from 1 through 4, they ask you to have decimal, then anything that you have to be dealing with should be decimals. Problem number 9-12, they're asking you to convert each of these numbers into a percent form. How are we going to do that? Well, in this case, they want you to have the percent symbol as a final answer. Okay, they want you to have that, give your answer with a percent symbol. So if you want to make this symbol, if you want to make that symbol, let's call here once again, you want to make the percent, let's call that, if you want to make the percent, that M is going to stand for multiply by 100%, pretty much by 100, and then you just attach the percent sign. So this 37 I have to multiply times 100, right? So we gotta multiply by 100. So 37 times 100%, well, 37 times 100, if you decide to use the shortcut, that should be move the point 2 decimal places to the right. So 1, 2. So it should be filled with 0, and that should be 3,700. They didn't specify if we have to convert that. Well, we're forgetting something very, very important, because the question was to write this with a percent symbol. Now you might ask me, well, why don't I give this with a decimal? Well, it was not necessary to give it a decimal. Then why don't I give this with a fraction? Well, you can see 37 times 100 is not a fraction. But if the case, in such case, for example, number 10, that they're giving you 0.043, so you have to make that a percent, so multiply times 100, or move the decimal spaces to the right. Yes, because we're working with whole numbers or decimals, you move them to the right. So that should be 4.3 percent, because you multiply that times 100. So times 100% was just to move that 2 places to the right. So it will be 4.3% as a final answer. Now, when am I going to do that of fractions, or what happened when I have fractions? In problem number 11, you're having 1.8, and they want you to write that as a percent. Well, once again, so you multiply times 100, so 1.8 times 1.8 times 100, so I'm going to have 1.8 times 100%. So let's do this the same way as we used to do. 1 over 8 is 4 times 2, 100 is 4 times 25 over 1. Now you can cancel out, because reduce if possible. You have 1 goes 1, 25 over 2%. Now you might ask, why can I convert this into a mixed numeral? Yes, you can convert to a mixed numeral. Do you need to? No, because remember, your answer must always be simplified, and 25 over 2 is simplified. To be simplified doesn't mean that it has to be a mixed numeral. So far 25 over 2 is great, so I would recommend you to just leave it like that. Now, in problem number 12, let's see what we have in problem number 12. They're still asking you convert each of these numbers. When they say numbers, you're talking about either decimal or fractions, because a fraction is still a number. Later on in algebra, you will see that those are called real numbers as well. So there's things that you will see later on in the future, but just giving you the vocabulary. Okay, so in number 12, it's gonna be 1 over 1 and 1/2. So you have to convert that into percent. You have to make that percent sign. So you gotta multiply this by 100%. But wait a minute, what's going on right now? You have to convert this mixed numeral into an improper fraction. 2 times 1 is 2 plus 1 is 3. So you have 3/2 times 100%. But recall this 100 is 100 over 1. So let's see if we can cancel something out. Well, that 100 is 2 times 50, and that 2 and the 2 can go away. So you're only left with 3 times 50, which is 150%. The bottom was 150. 1 over times 1 is 1. Having over 1 is the same thing as just having 150. So your final answer should be 150%, because that's what they want you. They want you to convert this with a percent sign. Problem 13. Draw a ring around the values that are smaller than 1 whole. So we're having here 8. The first option is 3%. The second option is 5/3. The third option is 70 and 2/3%, and the third option is 105%, and the last option is 7/9. If we recall what we learned through the whole semester, I'm just gonna do a quick review of what we covered earlier in the previous videos through the section of chapter 9. So what does it mean? Well, okay, there are 3 cases. We're just gonna point out 3 cases here. I will start first with numbers that are equal to 1. 1 whole is like one number, like number 1, like 1, like a full 1. Okay, now so let me see what numbers are first equal to 1. I will just do number equal to 1, or 1 whole. Well, the number 1 is equals to 1, or as well as, remember when you have 5 over 5 or 6 over 6. So if the numerator is the same as the denominator, so I'm going to write here numerator equal to denominator. So that's also when a number is equal to 1, right? So another case is when this is 100%. So let's keep that in yellow. So that should be 100%. So these are exactly the same as 1. So they're equal to 1 whole number. Now the second case is, let's go first for numbers that are more than 1. Than 1 whole. Well, in real numbers, we know the numbers that are more than 1 whole should be like 3, 4, 5, 6, 7, 8, 800. More than 1, like 2, 3, 4, 5. If you're with decimal, that should be 1.05, or numbers like 1.05, 4, 8. So more than 1 unit. Now, what about when we're having fractions? Well, numbers are as well more than 1 should be like when the numerator, the top part, let's say we have an 8 over 3. When the numerator is greater than the denominator. What we call those fractions, once again, we used to call them, or they are called, what are they called? They are called improper fraction. So I'm going to write here improper fraction. Improper fractions. So what other numbers, or now if we're talking about percent symbol, with the percent symbol, something that is more than one whole should be like more than 100%, like could be 102%, or could be 200%, 300%, 512%. So anything that is more than 100, like 101, 102, 103, 100.1, 100, and like could be 100 and 2/3%, because that's still more than 100, more than one whole, right, with the percent sign. So those are the numbers that are more than one whole. So what about the numbers that are less than one whole? I'm running out of space, so I want to try to shrink this here. So numbers that are less than one whole are actually, well, if you're talking about decimals, that should be 0 wholes there, right? You know, like it should be like 0.07 or 0.99. That's still less than one whole. If we're talking about a fraction, that could be like 2/5. Now, why 2/5? Well, because the numerator is less than denominator, and they were called proper fractions. Also, what other numbers are less than one whole are, well, numbers are less than 100%, like 78%, or 99% is still less than one whole. 99.05 is less than one whole. 10 2/3%, that's still less than one whole. So those are numbers that are less than one whole. So knowing that, like, we did a full review of this. So numbers that are less than one whole, if we remember these properties of each of them, then we can avoid to use our calculations. So let's see, what are we going to have here? Draw a ring around the values that are smaller than one whole. So numbers that are smaller than one whole, 3%. Of course, 3% is going to be less than one whole. It's less than 100. So I'm just going to write what are we finding here. This is less than 100. Therefore, it's less than one whole. So that's one of my answers. Let's use red. So I think red will be better. So this is my answer. Now, what other? 5/3. This is an improper fraction. So that's not an answer, because they want you to have smaller than, they want you to do smaller than one whole. So 70 and 2/3%, that's still less than 100%. So that's not 105%, that's more than 100%. So therefore, yes, that is more than one whole. 7/9. Wait. So that's more than one whole. So that should not be correct. So we did one mistake there. I'm sorry about it. So that should be not. So more than 100%, and we were looking for smaller. So smaller than number should be less than 100%. So now let's do 7/9. What is 7/9? Well, 7/9 is a proper fraction. Improper fractions are always less than one whole. Therefore, that is one of our answers. Okay, so that should be the only two numbers that are less than one whole are 3%, which is less than 100%, and 7/9, which is a proper fraction. So if you recall the rules that we learned earlier, these three rules, you will always have the right answer. If they change the word, they will say more than one whole, then you know where to look for. If they tell you equal to 1, then you know what to look for.